Ever wondered why some pumps fail prematurely, or why you hear strange noises coming from your pumping system? The answer often lies in a critical concept called net positive suction head, or NPSH, and its dangerous consequence, cavitation. Hello, mechanical engineers and plant maintenance professionals. Welcome to an in-depth look at NPSH and cavitation in pumps. Today, we'll demystify these crucial topics, covering NPSHA versus NPSHR, their causes, prevention strategies, and real-world plant examples. So what exactly is NPSH? Simply put, net positive suction head is the absolute pressure at the suction side of a pump minus the vapor pressure of the liquid, expressed in terms of head. It's a measure of the pressure energy available to push liquid into the pump impeller. When this pressure drops too low, especially below the liquid's vapor pressure, something dangerous happens, cavitation. This is the formation and collapse of vapor bubbles within the liquid, typically at the pump impeller's eye, due to localized pressure drops. The consequences of cavitation are severe, reduced pump performance, increased vibration, noise, and eventually, significant damage to the impeller and casing. It's a silent killer of pump efficiency and longevity. Now, let's differentiate between the two critical types of NPSH, NPSHA and NPSHR. This distinction is the golden rule for preventing cavitation. NPSHA, or net positive suction head available, is the absolute pressure at the suction port of the pump, minus the vapor pressure of the liquid, plus the velocity head, all expressed in feet or meters of liquid. It's what your system provides to the pump. Factors affecting NPSHA include atmospheric pressure, liquid level in the suction tank, friction losses in the suction piping, and the liquid's vapor pressure, which is temperature dependent. Higher temperature means higher vapor pressure, reducing NPSHA. Here's the formula for NPSHA. NPSHA equals plus. Let's consider a plant example. A cooling water pump drawing from an open tank. NPSHR, or net positive suction head required, is the minimum absolute pressure required at the suction port of the pump to prevent cavitation. It's what the pump needs to operate without cavitating, determined by the pump manufacturer through testing. NPSHR is primarily a function of the pump's design, speed, and flow rate. It's typically found on pump performance curves provided by the manufacturer. The key difference is simple. NPSHA is a characteristic of your system, while NPSHR is a characteristic of the pump itself. You calculate NPSHA and you look up NPSHR. The golden rule: NPSHA must always be greater than NPSHR. If NPSHA is less than NPSHR, even by a small margin, cavitation will occur. So what happens if NPSHA and NPSHR? You get all the negative effects we discussed: noise, vibration, reduced efficiency, and ultimately, pump failure. This is a critical operational parameter. How can we improve NPSHA? Several strategies exist. 1. Increase suction pressure by raising the liquid level in the tank. 2. Reduce friction losses by using larger diameter pipes or fewer fittings. 3. Lower the liquid temperature to decrease vapor pressure. 4. Use a booster pump. For plant maintenance professionals, regular inspection of suction piping for corrosion or blockages and ensuring proper liquid levels and temperatures are key preventive measures. Let's consider a real-life scenario: a slurry pump in a mining operation. Slurry is abrasive and often hot, leading to high vapor pressure and increased friction losses. Maintaining adequate NPSHA is extremely challenging but vital. In such cases, engineers might opt for vertical pumps with submerged impellers or carefully designed suction lines with minimal bends and large diameters to maximize NPSHA and prevent costly cavitation damage. In conclusion, understanding NPSH and cavitation is fundamental for reliable pump operation. Remember, NPSHA is what your system provides, NPSHR is what your pump needs, and NPSHA must always be greater than NPSHR. Thank you for watching. If you found this video helpful, please like, share, and subscribe for more engineering insights. Leave your questions and experiences with NPSH and cavitation in the comments below.